Hi, I am Alexander, Assistant Professor in Department of Computer Science and Engineering, St.Joseph College of Engineering, Autonomous, YMR. Today we discuss the quick start problem solved by divide and conquer method in design and analysis of algorithm subjects. Problem, you arrange the values in ascending order. We store the values in array. Name of the array is A. Name of the array is A. We need to follow the four steps in this algorithm to solve the quick start problem. First I choose the pivot element is the 50. So we can choose the pivot element first element or last element. Either you can choose, but I choose the pivot element is the 50 first element. This is a low. Low is assigned the pivot and high is assigned the value is j. The first condition you check A of pivot. So I value is moved to 30. First condition check the A of P and A of I. A of P greater of A of I. Then the I value increment by 1. I value increment by 1. It is the first condition. So here the P value is the 50. I value is 30, the condition true, I value move to 10, 50, 30, 10, 90, 80, 20, 40, then 70. 70 is a J, now I is the 10, pivot is the 50. Again check the condition, A of P greater of A of I, the condition 50, then 10, the condition true, I increment by 1. Now I value move to 90. Again write the array value 50, 30, 10, 90, 80, 20, 40, then 70. So it's a pivot, it is I. So now check the again this condition A of P greater of A of I. So P value 50, I value 90, so false. So stop increment I, stop increment I. Then check the second condition, condition number 2, A of P is lesser of A of J. If condition is a true, J decrement by 1. J decrement by 1. So check this 50, 30, 10, 90, 80, 20, 40, then 70. It is a J, it is a P, it is I. So A of P less than A of J. So P of P value 50, J value 70, condition true, J decrement by 1. J decrement by 1. So J value move to 40. J value move to 40, 30, 10, 90, 80, 20, 40, then 70, J value move to pivot this I. Okay. Here check the A of P greater of A of I, 50, 30 condition false. Then check the A of P and less than of A of J, 50, then 40, the condition also false. In this situation, check A of P less than of A of I and A of P greater of A of J. If both condition true, swap A of I comma A of J. So value for P is 50, I value is 90, condition true, A of P is 50, A of J is 40. So 90 move to 40, the 40 move to 90 position. So now write the value 50, 30, 10, 40, 80, 20, then 90, then 70. This is J, I value is 40, pivot is 50. Again this is the condition, this is the condition 3. This is the condition 3. So now check the condition again 1, A of P greater of A of I, the condition true, 50, then 40, then I increment by 1. So I value move to 80. I value move to 80. So check the condition. A of P greater of A of J is a false. Stop I increment. Stop I increment. Then check the condition J. So write the again 50, 30, 10, 40, 80, 20, 90, then 70 is I value, it is a P value. So condition 2 is A of P greater of A of J. The condition true, J decrement by 1. Now J come to 20. 50, 30, 10, 40, 80, 20, 90, then 70, it is a J, it is I. Again the condition false, that means A of P lesser of A of I, then A of P greater of A of J. Now swap the value A of I and A of J. The condition 3. Condition 3. So 50, 30, 10, 40, 20, 80, 90, then 70, this I, it is a J, it is a P. So now check the first condition. A of P greater of A of I, yes, condition true, I increment by 1, I increment by 1, I value move to 80. So 50, 30, 10, 40, 20, 80, 90, 70. So I, J in 80 position. So here check A of pivot and A of I, the condition false, stop, increment I. So check the condition 2, A of P less than of A of J. This condition is true actually. So J decrement by 1. J decrement by 1. So 50, 30, 10, 40, 20, 80, 90, then 70, say pivot, then I value is 80, J value is 20. So very important things. When the J cross I, when J cross I, when the J cross I, because I, so increment from pivot to J, but J is a decrement from high to low. When cross the J from I, we swap the condition is a 4. When cross the I comma J, swap A of pivot comma A of J, the fourth condition. So 20 come to 50, the 50 goes to 20 position. So 20, 30, 10, 40, then 50, then 80, then 90, then 70. This is the pivot element. Once the pivot element is swapped, okay, you split the two sublist. Okay, it is a very important stage. Check the pivot element, the left sublist value having lesser of the pivot. These values are lesser of the pivot. The right sublist value having the greater of the pivot. Okay, greater of the should be greater of the pivot. Right, it is a left sublist, it is a right sublist. Again you take the left sublist, so it is assigned the pivot, it is I, it is a J. Again do the same procedure to solve the left sublist array. So check the I value, so P then I is a greater, so I no increment. Then check with the j, 10, 40. Here a of p greater of a of I, condition false. So go to j, so a of p, then a of j, the condition is true, j decrement by 1. Now j value come to 10, 20, 30, 10, 40. This is a condition 1, the condition 2. It is a j, it is I, it is a p. This statement satisfies the condition 3. Satisfy the condition 3, the swap a of I, comma a of j. So 20, 10, 30, then 40. It's I, this is j, it is a pivot. So we have the value 20, 10, 30, then 40. It is a p, it is I, it is a j. So pivot, the I value is a lesser, I value move to 30. I value move to 30, I comma j. Now comparing pivot, I is the greater, stop the I increment, then check the j. J is the greater of pivot, j now decrement by 1. J decrement by 1, j decrement by 1. So now satisfied the condition 4. So swap a of j, comma swap a of p, comma a of j, a of p, comma a of j. So 10, 20, 30, then 40. Okay, so left side array started, left side sublist are started. Now so move to right side sublist. Right side sublist, you have the value, the pivot element is a 50. So right side sublist value 80, 90, then 70. This is a pivot, this is I, it is a j. So pivot is greater of I, so no increment in I, then check with the j, is a lesser of p. You swap the satisfies the condition 3, swap a of I, comma a of j. So 80, 70, then 90, p, I, j. Now the condition, first condition is condition number 1 is satisfied. A of p lesser of a of I, so I increment by 1, so I value move to 90, 80, 70, 90, I comma j. Now next I value, I condition false, then j decrement by 1, j decrement by 1. When I cross j, you swap the I comma pivot, the 70, 80, then 90. The condition number, this is a 4. So right side sublist also sorted, the pivot element is the 50, the left side sublist value 10, 20, 30, 40. And left sublist are sorted, this is a pivot, right sublist are value also sorted. So you taken the values unsorted array, and finally we sorted the values in ascending order using quick sort in divide and conquer method. So first to form the regression equation for the quick start. Now here you solve the quick start problem divide and conquer method. So form the regression equation t of n equal to t of n by 2 plus t of n by 2 plus n. This t of n by 2 the required time for divide the left sublist. Required time for divide the left sublist. This t of n by 2 required for divide the required time for divide the right sublist. It is a n. It is a required time for divide the sublist array. So this is on the required time for left sublist. This is required for right. Required time for right sublist array. This is required time for divide the entire array. Divide the entire array. So add the t of n by 2, t of n by 2, 2 t of n by 2 plus n. This is a regression equation. The regression equation we can solve the three way. So one is the substitution method, second one master method, third one tree method. In substitution method having two types, one is a forward substitution and a backward substitution. I will discuss the backward substitution. So take the equation t of n, 2t of n by 2 plus n. The backward substitution means you find the equation for t of n by 2. That means the n replaced by n by 2. The n value replaced by n by 2. N value replaced by n by 2. So n value replaced by n by 2. N value replaced by n by 2 equal to 2t. N replaced by n by 2 means n by 4 plus this n replaced by n by 2. This is the equation number. This is a 1, this is a 2. Again you find the n by 4. That means the n value replaced by n by 4. The n value replaced by n by 4. About t of n by 4 equal to 2t. In replace in equation number 1. Replace in equation number 1, not equation number 2. Right? Now n value replaced by n by 4, we get n by 8 plus n by 4. The equation number 3. It's enough. The 2 and 3 equation, now we substitute in equation number 1. The equation number 1, t of n equal to 2t n by 2 plus n. So t of n by 2 answer, the equation number 2. The equation number 2 is 2t n by 4 plus n by 2 plus n. So 4t n by 4 cancel the 2 comma 2 plus n. So 2n. The equation is 4t n by 4 plus 2n. Now the n by 4 replaced by equation number 3. Equation number 3. Right? So 4 bracket 2t n by 8 plus n by 4. 2t n by 8 plus n by 4 plus 2n plus 2n. 4 into 2 8t n by 8. The 4 cancel plus n plus 2n n plus 2n. So 8t then n by 8 plus 3n. Take this equation 8t n by 8 plus 3n. The 2 we can write 2 power 3 t n by 2 power 3 plus 3n. So initially here we assume t of 0 equal to 1, t of 1 equal to 0, t of 1 equal to, you take t of 1 equal to 0. Now you take k equal to 3. So 2 power k t n and 2 power k plus k into n. Right? Now you take n equal to 2 power k. Then k equal to n log 2n. k equal to n log 2n. Substitute the value. This is a n t n divided by n plus k. Yes, n equal to 2k, then k equal to log 2n plus log 2n dot n, right? So n into t of 1 plus log 2n dot n. So t of 1 equal to 0, assume this term is a 0, then n dot log 2n. So t of n equal to n dot log 2n. In time complexity of quick start is t of n equal to big O of log 2n. It is a best case analysis of time complexity of quick start.
Ready?
So next you solve the regression equation using master method. So master method. If f of n is n power d, the d value should be greater or equal to of 0, having 3 steps. The t of n equal to theta of n power d if a less than b power d. The second one, t of n theta of n power d log 2n if a double equal to b. The third condition is t of n theta of n power log b power a if a greater b power d. It is a master method theorem. The equation match the master method. T of n equal to a t n by b plus f of n. A t n by b plus f of n. So our equation is t of n equal to 2t n by 2 plus n. So match the both equation. Here a equal to 2, b equal to 2, n f of n equal to f of n equal to n. That means f of n means n power d. So n power d equal to n power 1. So d equal to answer 1. Right? Write the equations. A value a, then b power d, a value 2, b value 2, d value 1. So 2 double equal to 2. So yes, this equation satisfied the a double equal to b power d. So satisfy the equation number 2. So the equation number 2, the time complexity equation, t of n equal to theta of n power d log 2 power n. So theta of n power d value 1. So log 2 power n. So n value 1. So theta equal to n dot log 2n. So time complexity t of n equal to log 2n. So previously we discussed to find the time complexity using substitution method, we got the same answer. Using master method, we got the same answer. Time complexity t of n equal to theta of log 2n. It is a time complexity. It is a best case of quick start algorithm. So that's all. Thank you all. Thank you for watching. I hope you learned the quick start problem and time complexity. If you any query, ping me.